And unfortunately, I kind of lost my bookmark, so I might need your help. I know we went through steps for U subs. I think we did one example, and then I'll write down what the next example is. If you've already done that one, let me know. So we've reached 5.5. It's like substitution, usually use substitution, but you can use any symbol for your substitution. Okay, we went through the steps. And then we did this integral. It was the cubed root of 1 minus 5x dx. Okay, then we chose everything under the root to be our function or our substitution or u sub. And we got, let's see, -3 over 20. Times 1 minus 5x to the 4/3. Let's see. Okay, so the next integral is x times e to the power 5x squared minus 1 dx. Okay, my, I guess, advice is to pick a kind of messy part of this kind of product, which is this, for me, it's this part, all of the values that make up this exponent. The 5x squared minus 1 is going to be my substitution. Okay, then we're doing a derivative. Take the derivative of u with respect to x, u dx. Or, u prime is equal to 10x. Or actually, sorry, before we keep going, did someone, or like Andy or Alana, did you take notes and did we do this example already?
I know I never seen it, but I did see the last example, the first one you put up. Yeah, I think we did that one. I forgot where the 4/3 come from.
Yeah, okay. Thank you. Okay, I just want to make sure I didn't I'm not repeating myself, but.
Yeah, but where did 4/3 come from, by the way?
The 4/3 comes from having a power, this written as a power of 1/3. And then when you integrate, they'll add 1 to that power and get 4/3.
Okay.
Yeah, like this, like backing up. And then when we did this example, we let u be the 1 minus 5x. And then that has power 1/3. And again, you're going to add 1 to the power. If we have time at the end, we can go back through this example. But since we did this one yesterday, I'm going to leave it here for now. And we're going to keep going through the other ones that I've got. But I'll put a star here. We can come back to this. All right, so let's continue with taking the derivative here, the scratch work for this problem. And I like to solve for dx. So, I mean, I know this kind of just a notation thing, but still, this is kind of how it's done in the book. It's how it's done, how I did it when I was taught. So it's like you multiply both sides by dx. Then I would divide both sides by 10x. Now you've solved for dx in terms of du. And also like this, see, when we substitute this in, this x and that x are going to cancel. All right, let's do that. Okay, so we're taking our integral of x times e to power 5x squared minus 1, but we're going to put in u. So we've done our substitution, and we're also going to replace dx. So that dx right there is going to be subbed in right there. And we're putting in du over 10x. Then you've got this x over x, which would be 1, except for, for x equal to 0. And we're left with 1/10 times e to the u. And it's just easier to read if we bring that 1/10 out in front of the integral. And it's multiplied with the integral of e to the u du. All right, so this is much easier to work with. The integral of e to the u is e to the u plus c.
Wait, hold on. Can you give us some time to look at it?
Yeah.
Wait, so the 5x squared minus 1 just becomes u?
Yeah, I think it just raised that part, but we just picked that exponent to be u, or just chose that as our substitution.
Mhm. Okay, and after that, so eventually, so you times x with du over 10x, and eventually the x becomes 1, and you keep the du on that side, but 1 over 10 still same thing, still means same thing, right? Like
Yeah.
you can keep it inside the bracket or outside the bracket.
It could stay inside. You could keep it in, like,
Okay,
you could put it here.
same thing.
Yeah, it's the same.
Okay, thank you.
Okay, so then I'm gonna need to. Okay, so there's this 1/10. times the integral of e to the u, which is e to the u. And then you get that plus c since it's an indefinite integral. And then you want to finish the problem by putting everything in terms of x. So put that u back into that power. Replace u with that 5x squared minus 1. It's a little sloppy. Okay, and then we're done. So that would be,
That's the final answer.
yeah.
So where did that bracket go? This just disappeared?
This one?
Yeah.
Yeah, once you've integrated or taken the integral, you don't need the sign anymore. Just like the integral of this value, and then you have integrated it. You found the antiderivative, so you don't need this symbol after that. Okay, gonna get ready for the next one. Okay, we want an integral of ln of x cubed, so like the whole ln of x as that power. And then divide by x. And then dx. Okay, so sometimes it might take like a little bit of like guess and check to find a good substitution. For this problem though, I'm going to go with u equal to ln of x. Then you want to take the derivative, so du dx. And the derivative of ln of x is 1 over x. Okay. Here. Okay. I like to solve for dx, so I would multiply both sides by dx. And then multiply both sides by x. Cool. And then let's try writing the integral and then doing the u sub and then replace that dx with this dx. It's an integral of ln of x cubed. Over x dx is So first thing is just to do the substitution. Cool. So it's u cubed over x dx. That right in there, and then we've got that there, and replace this here. So for this dx, put in this guy. Here, okay, dx is equal to x times, or x du, I guess x times du. And then we've got this x over that x, which would be 1, and you're left with u cubed du, an integral of u cubed du. Can you see this? No, I don't think so. Okay, so. Gone through, and the integral of u cubed will be u to the 4th over 4 plus c.
Where did the x come from? The x in the
Oops.
yeah. Where did that x come from?
This one?
Yeah. Yes.
It comes from the
Oh,
is when we
and
solve for dx.
oh, so the d just disappears then?
We had dx written in terms of like du and also like this x. So let's do it right here. So back to that scratch work was I just erased, but we can do it again. So we chose u to be ln of x. And then we took the derivative. And then we solved for dx. So I multiply both sides by x dx. So we have a x du equals dx. So that's where that x comes from. It's taking this dx right here, do it like this, and then replacing it with, it's equal to that part right there.
Is that trigonometry stuff, by the way?
No, this is like I guess like an algebra trick when you do a substitution, and it just makes the integral much easier to work with. So you pick some part of the integral that's tricky, and like, difficult, and you just call it something. We're going to call it u. And then for integrals, it helps to like take that u value or that u function, get the derivative, rewrite your integral, integrate, which I think we just did, and then go back to having your answer in terms of x. So I'm gonna write the answer down, but I think in the next one it will help if we like change it up with our symbols. Okay, so this one would be ln of x is equal to u, so we're putting it back right here. ln to the power of 4 divided by 4 plus c. Okay. I think what would be best is if we just do as many examples as we can. So for the next one, we're doing okay. What we're going to do is an integral and we're going to write this as e to power u over 1 plus e to the u du. So in this integral, they've already used the variable u, or that symbol's already like a part of the problem. So it would be best to choose some other symbol that's not u and still do a substitution. And that way we can like actually find this integral. It makes it much easier to find the integral. Okay, I think the book likes to use t or like some other letter. I've had a teacher in the past who would use like a little lightning bolt sign, like that was their symbol. We can use a smiley face if you want to. I'm gonna just go with some letter.
By the way, for the exponent for the U3, you did an antiderivative, right?
Yeah.
Okay.
Let's just use t. Okay, so we're gonna do a t substitution. Okay, so you want to find a part of this integral that we're going to set equal to t. And I'm going to use that denominator. So I'm going to let t be 1 plus e to the u. And then the next thing to do is a derivative. So take the derivative of t with respect to u, dt du. Sweet. All right. This derivative, here you have a 0, here you have e to the u. Okay, so just like to point out, we're going to replace this denominator with that substitution with that value of t. That's going to kind of sit there for a moment. And we're also going to replace du. So I'd like to solve for du by multiplying both sides by du and then dividing both sides by e to the u. So let's multiply both sides by du. And I'm trying to like isolate this du, so I can kind of replace it with dt over d, e to the u. So I just like divide both sides by e to the u, and then we're going to rewrite our integral. So this integral is, I think we're going to just substitute. So do the substitution. Which means, the t sub. So put in t for 1 plus c to the u. Okay. So in our scratch work, we solved for du, and I'm going to put that in right there for this du. Place this du with that du. Right now I've got e to the u over t. And I want to replace du with dt over e to the u. Okay, cool. So with e to the u over e to the u, it's going to reduce to 1. And then you're left with 1 over t dt. Okay, and then you integrate, which means you're going to find an antiderivative for that 1 over t, which is ln of the absolute value of t, and then plus c. Okay, the last thing to do is get everything back in terms of the original variable, which was u. So we have an ln absolute value of 1 plus e to the u plus c. Okay, that's your answer. The next integral is also going to use the variable u, so we'll probably do another.
Oh, wait, these last notes, they're in online, right?
Yes, yeah. I posted it yesterday. Okay, so let's see. You're gonna use some other kind of letter for your substitution. Something other than u, because we're gonna do an integral of u times 3u squared minus 1 squared. So 3u squared minus 1 du. So this piece here, this 3u squared minus 1, that's what I want to use. That's what I'm going to try to substitute with some kind of letter other than u, or some symbol. Let's just stick with T. It seems easy. I mean, you don't have to use T. Again, it can be anything you want it to be. But my name is pick some kind of. Actually, let's go. I kind of like W. I know it's kind of close to you. Now it's too close to you. Let's try Z. We're going to do a Z sub. Excuse me. So I want to put Z equal to 3u squared minus 1. Okay, then we're going to do a derivative and get the derivative of Z with respect to u, dz du. Then over here, the derivative would be a 6u minus 0, 6u. So we're going to be substituting z in right here. I'd also like to replace this du over there. So I'm going to use this scratch work to get du. So you like multiply both sides by du to get 6u du equal to dz. And I would divide both sides by 6u. And you've got dz over 6u equal to du.
Where did the Z come from?
Oh, I just picked some symbol for a substitution and I chose Z. Since the problem is already using u. So you can pick any letter.
Oh, you only pick any other letter if like the example has like a U in there or something?
Yeah.
Okay.
Because it would get really weird, or it could be confusing having like
It's weird, but we like have all kinds of variables, you know. It's for I'm trying to figure out like why it's called U sub, you know.
Yeah,
It could be any letter.
it can be any letter. If it's not used, like if it's an x, if it's a integral in terms of x, then it's common to pick u as your symbol. But if your problem has u, then you want to pick another symbol. I just picked a Z. But you can pick like a Greek letter. You can make a little, something like a hashtag. You can use any kind of symbol that I would pick that's like kind of easy to draw. But still, you could even pick a smiley face. Okay, let's keep going with isolating this du and having it equal to dz over 6u. Then we can take this problem and make it much easier to work with. So we're going to go from here to an integral of u times z squared du. So I've substituted in my value of z for my function. And we're going to replace du with dz over 6u. And this u over that u, which hopefully you can see, reduces to 1 for all values of u except for 0. And you're left with a z squared dz, an integral of z squared dz.
I have a question, Professor. Where did you get the 6u for the bottom, for the denominator, for the bottom equation on the right whiteboard?
Yeah.
Where did 6u come from? Where did that 6u come from?
It comes from like doing your derivative. So you get your substitution set up, take the derivative, which that's your 6u right there. And then we did more scratch work to get du written as dz over 6u. So yeah, from here to here, derivative. And on this side, you get your 6u. And then I multiplied both sides by du to get to here. Then I divided both sides by this 6u to get to there. And then we just took this du right here and put it in right there.
Okay.
So from like here to here, take this du and replace it with the dz over 6u. Okay, so we're at 1/6 times the integral of z squared dz. So that's 6. Oh, question. Okay, thanks for the comment. excuse me. Okay. So again, keep asking questions whenever you're feeling confused, but I think, again, like as many examples as we can do will help this be more clear. So I'm just gonna kind of push through to the answer of this one, and then we can like hopefully get into another example. So I brought that 6 down there to the front. I've got 1/6 times the integral of z squared dz. Okay. So, like we talked about earlier, when you find the integral or when you integrate, you don't need the symbol anymore, like this part. So we have a 1/6, and then from here we're gonna add 1 to the power of z cubed, and then divide by 3. And plus c. And we're at z cubed over 6 plus c. Or, sorry, z cubed over 18. And the problem started in terms of u, and you want it to end in terms of u. So you want to put the value of z back into the problem. It was that 3u squared minus 1.
And that's the answer.
And that's the answer. U squared minus 1 cubed over 18 plus c. Cool. So I got 2 more in my notes, and then if we have time today, maybe even tomorrow, we'll do a couple from the book. All right. This is the integral of the product of 18x minus 15. And 3x squared minus 5x plus 1, and that quantity is squared. And dx. See. Try this again. So I kind of showed it in my notes that I posted online. If you want to do like a little scratch work, because maybe you don't know which part of the problem is best to choose for your substitution, like maybe this part, maybe that part. So I gave it a try for either one. And in one of them, you get a little stuck, like you don't really have a good integral to work with. But when you do the other substitution and a little bit of factoring, the problem's like pretty quick. So the first thing I want to do actually is just factor. And from that first pair of parentheses, we're going to take out, factored out 3, and maybe just bring that to the front of the integral. Factoring this 3 out would leave a 6x minus 5. And this stays the same. And you know what, I want to leave this integral sitting here and go on the side, like if you're taking notes, maybe go somewhere else on the page and do some scratch work. And pick some u substitution. I'm going to pick the 3x squared minus 5x plus 1 and let that equal u. Okay, and I just ran out of time. So if you have time, I suggest that you've tried finishing the problem and getting, trying to see like what you get as an answer. And then tomorrow in class, we'll finish it together. We'll do another example and maybe like a couple on the side. And then we'll review for the final. Which also, this was the very last Zoom meeting. So thank you for doing the online classes, especially at the beginning of the semester. I'm excited that we're almost at the end of the notes. This is the second to last example. So I'm so happy that we made it to our goal. Thanks again, everybody.